Hello everyone, welcome back to Math Online. I'm Mr. Solis, and on today's video we will learn about sine and cosine ratios. So today's objective is students will be able to use the side lanes of a right triangle to find the sine and cosine ratio. So similar to the previous video, when we looked at tangent ratios, hopefully you watched the entire video and you were able to subscribe and support the channel by dropping a thumbs up. Alright, well anyways, so hopefully you saw the other video. If you did, it will make your life easier when it comes to sine and cosine because you already have an idea of what to do. Okay, if you haven't watched the tangent ratio video, please go back and watch the other video first and then watch this one. Okay, so here we go then. So just like the previous video about tangent ratios, all we need is two sides only, right? A right triangle has three sides, all we need is two. Okay, now similarly, we're going to do the same thing with sine and cosine, but just a reminder of what we talked about on the previous video. We need two things. We need to identify two things. First of all, where is the 90-degree angle? And where is the angle of interest? Okay, so two things that we need: angle of interest and the 90-degree angle. All right, here's the thing. First of all, we look for the box. Oh, where's the box? There it is. That's the 90-degree angle. So therefore, we know that across the 90-degree angle, we will always find the hypotenuse, right? We talked about that previously, okay, on the previous video. Now, let's start off with sine of angle A, okay? Sine of angle A is telling us that the angle of interest is angle A, right? So therefore, I'm going to use a different color. This is the angle of interest for sine, okay? So we're going to circle angle A since that's the angle of interest. And we learned on the previous video that across the angle of interest, you will always find what side? And hopefully 209 of you guys are screaming opposite side. All right, awesome. So we're going to label this with the O for opposite, okay? Now, we know the hypotenuse, so which I should have labeled with an H. So we already know the side, the longest side is the hypotenuse. We know that this side is the opposite side. Therefore, by default, this side should be known as the adjacent side. Awesome. I'm going to put an A for adjacent. Okay, good. Awesome. All right. Now, when it comes to the ratios, here's the thing. When it comes to sine of any angle, right? It could be any angle. When you're looking at sine and you want to find the ratio, all you need is two sides of the right triangle. And the sides that you need are the following. For sine, you need opposite over hypotenuse. That's what you need for sine. All the time, it never changes, guys. The sine ratio will always be the same. Opposite over hypotenuse. Okay? Now, on the other hand, I noticed that I'm using the same angle of interest, making everything easier. This could change, so just keep that in mind. So for cosine of angle A, right? So we say, okay, we identify that the 90-degree angle is here. Across from it, we see hypotenuse. Since the angle of interest is A, right? So check. This will be the angle of interest, since that was the angle that was given. Across from that, we see the opposite side. Therefore, by default, you know, this side should be adjacent. So on cosine, the two sides that you need on a right triangle is the following. All we need is the adjacent side over the hypotenuse. So hopefully you guys remember what I said on the previous video. For tangent, you don't need hypotenuse. We didn't use hypotenuse at all. But for sine and cosine, we need the hypotenuse. Okay, that's how it works. So for sine and cosine, you do need the hypotenuse. It's very important. So make sure you memorize these ratios. They will never change. Okay, so sine, you need opposite over hypotenuse. For cosine, you need adjacent over hypotenuse. Okay, all right. So let's do this then. Let's move on to some scenarios, and we already have some background on how to find tangent ratios. It will be really similar. Just remember these ratios here. Okay, guys, super important. Memorize them. Okay, don't forget the tangent one as well. All right, moving on to the next slide. All right. So now we have a scenario here. Example number 1 tells us use the triangle to write each ratio. So they're asking us to find the sine of angle A. So therefore, they're asking us for the ratio that corresponds to sine of angle A. So here's the thing. First of all, we've been talking about this, okay, since the previous video. We need to figure out or find out where, whoops, that's way too big. Let me make this smaller. Let's hit enter. Great, awesome. So we need to identify the 90-degree angle. Okay, first step. Then we need to identify what is the angle of interest. Okay, we need those two things. So I'm actually going to copy this so that I don't have to write it over and over again. So copy, and it should let us paste it, okay, on the next slide. All right, so we need those two things: identify where the 90-degree angle is, identify what the angle of interest is, okay? Now, the 90-degree angle is really easy to find. You just have to look for the box. So in this case, oh, there's the box. So angle B, it measures 90 degrees, right? So just keep in mind, let's label our sides. We need to know what the names are, okay? So across the 90-degree angles, we will always find what side, class? Hypotenuse. Everybody was screaming hypotenuse. Awesome. Good job, guys. You guys are doing amazing. So yes, across the 90-degree box, across the 90-degree angle, you will always find the hypotenuse. Awesome. All right. So now, next thing, I'm going to check this off because we already got it. Now, what is the angle of interest? Well, the angle of interest will always be on your problem. Look at your problem. Part A. Sine of what angle? A. Sine of what angle? A. Therefore, this is the angle of interest. So I'm going to go and circle angle A. Angle A is right here. Now, across angle A, right, we always find what side? Opposite side. Always. Across the angle of interest, this is the angle of interest, you always find the opposite side, okay, across from this angle. Now, by default, this side should be known as adjacent side. Yay, you guys got it. Awesome. All right, so just keep in mind. Okay, I'm going to see if I could write this down as nice and neat as I can. Remember, I'm using a mouse, so it's hard to write with this. Okay, sine of any angle. In this case, I'm just going to, whoops. Oh, that's horrible, guys. Let me go back. Oh, I actually erased everything. So sine of any angle, let's say angle A in this case. I'm going to actually use parentheses in this case. Sine of any angle, the angle could be any degrees. So sine of A now. So now I was able to write it out finally. All right. So sine of A, the ratio will always be equal to opposite over hypotenuse. We talked about this, right? Hopefully you memorized this already. So that's all we need. Just the ratio, just the fraction, number on top, number on the bottom. That's it for today, okay? And remember, if you have to reduce your fraction, reduce it, okay? So here we go. So sine of A is equal to what ratio? All right, we need opposite side. What's the opposite side? Oh, the opposite side is this side, which is 8. So I need an 8 here on the top. Boom, there it is. Now, hypotenuse, where's the hypotenuse? Oh, there's a hypotenuse, the longest side of the right triangle, which is 17. So I put a 17 down here, and can I reduce this fraction? No, I can, right? Because the greatest common factor is 1. So therefore, it's just going to leave us with 8 over 17. So therefore, this is our answer. So I'm going to go ahead and actually circle the whole thing because I don't want you guys to get confused. I'm going to write the whole thing. There it is. Awesome. Okay, so sine of A is equal to 8 over 17. All right, so next scenario. Hopefully you guys are starting to get this. Remember, just the only thing that changes is the ratios. Sine, cosine, tangent. That's the only difference. The steps are the same. Identify the 90-degree angle. Find it across from it. You always find hypotenuse. Look for your angle of interest. It's always on the problem right here. So the angle of interest is here. It's A. Across from it, you always find the O, the opposite side. And then the remaining side has to be adjacent. Okay? All right. So here we go then. Next scenario. So in this case, we have example 1, part B, cosine of angle A. So once again, remember what I said? I was going to copy and paste. So paste. Oh, those are the two things that we need. The 90-degree angle and the angle of interest. So here we go again. Okay. Oh, and let's keep in mind before we move on, the cosine ratio for any angle. I'll put parentheses because remember the angles will change eventually. They will not just be letters, they'll be numbers, but that's for another lesson. Okay, so cosine of A is equal to, and we said that the ratio is adjacent over hypotenuse. Am I getting better at writing with the mouse, guys? It seems like, you know, those letters are more reasonable than the previous ones. Hey, from tangent, if you saw the video, horrible at the end. I try to do my best, but, you know, Anyways, so cosine of A is equal to a ratio. What is that ratio? Well, first of all, let's look for the 90-degree angle, okay? Let's look for that. So I don't know why I checked it off. We haven't found it yet, but let's go and look for the box. All right, there's the box, guys. So this is the 90-degree angle, and across the 90-degree angle, we always find what side of the right triangle? Hypotenuse. Great, awesome. You guys got it. All right, next one. So now we're looking for the angle of interest. And the angle of interest is always found on the problem. Oh, here it is. Angle of interest is A. So therefore, here is A. So across from the angle of interest, you will always find what side? The opposite side. Whatever's remaining is known as the adjacent side. Okay. All right. So for cosine, all we need is the adjacent side over hypotenuse. So the adjacent side is here, is 15 units. So the 15 goes on the top over the hypotenuse length, which is, in this case, 17. H is here, hypotenuse, 17. Okay, good. So 17 right there. And we're done. That's it. Can we reduce this fraction? No, we can. That's it. All right. So this should be our answer right there. Boom, we're done. I could have just circled the ratio. I circled the whole thing for you guys. Anyways, you guys get the deal. Okay. All right. Let's go ahead and do one more example. Hopefully you guys are starting to get this. So example 1, use a triangle to write each ratio. So in part C, they're asking us sine of angle C. Find the ratio of sine of angle C. All right, so once again, keep in mind, we need to find the 90-degree angle, which is the box, and we need to find the angle of interest, which is always located on the problem itself, okay? All right, so first of all, let's look for the 90-degree angle. Oh, there's a box. So across from the box, across from the 90-degree angle, we always find the hypotenuse. Great. So check that off. Boom. There it is. Awesome. Now, we need to find the angle of interest. The angle of interest is always on the problem. Sine of what angle? Oh, angle C. So therefore, we're going to look for C. C is up here now. See, things could change, guys. Actually, let me circle this in blue. That looks horrible now. So I'm going to circle angle C in blue now. That's the angle of interest. So across the angle of interest, you will always find what side? Opposite side. Yay, you guys got it. Awesome. So now we got the opposite side, we got the hypotenuse side, so therefore by default this side should be the adjacent side. Awesome. Now we need to write the ratio. Hopefully you guys remember that for sine all we need is the opposite side over the hypotenuse. If you forgot, please go back to this video, rewind the tape, and you'll see that the sine for any angle will be the ratio opposite over hypotenuse. So in this case, sine is O over H. So O is 15 units. So 15 units over 17, which is the hypotenuse. Awesome. And that's it. Okay. Like I said, hopefully this was helpful. If you guys have any questions, send me an email. And remember, we teach a new lesson like this one almost every single day. I'm Mr. Solis, and I'll see you on the next one.